Today we are talking about AR15 gas system and buffer 101. Hey guys, my name is Dave Tim. Thank you very much for checking out this video. We actually received a viewer request, it was a social media comment, asking about AR15 gas and buffer type 101, what the differences are between the different gas systems for your AR15 and buffer basics. So that's what this video is going to, kind of dive into. This is going to be a very basic kind of intro type course to the gas system because truthfully it can be complex depending on a variety of things, which we'll kind of get into. And then we'll also start to talk about buffers just a little bit. There are a wide variety of buffer products now on the market with spring systems, different weights, dampening products, etc. So we're not going to dive into all of that right now, but we're going to scratch the surface. And if we want to maybe do another video in the future where we get into more detail on specific products, we certainly can do that. Now, the AR15 is a gas-operated rifle. I'm talking about the direct impingement gun. I know there are piston guns, and I'm very familiar with a lot of those. I used to work for a company that was in the piston rifle business. But for the purposes of this video, we're talking about direct impingement rifles, which basically means we have a gas block, a gas tube, and a traditional bolt carrier inside the upper receiver that the gas is used to cycle the rifle. Now, there are different things that affect the cycling of the rifle. Number one, the cartridge itself, the amount of powder, the pressure, the load, that really does matter. There are differences between 223 loads, 556 loads. There are differences between cheap practice loads or import loads versus duty and hunting loads, or even XM193. And a lot of people say, well, ammo is ammo, and as long as it's loaded to spec, it's the same. Well, no, it's not. If you shoot some Wolf 55 grain steel cased ammo, bang, 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 and then you load in some Federal XM193, there's a difference, not only in felt recoil, but noticeably in the percussion and the amount of energy between those two rounds. That makes a difference. Additionally, the chamber makes a difference. How is the barrel cut? Here is the chamber of the barrel, and when you're looking at that, it's not quite as easy to tell what it is without the proper gauges and equipment. But how this chamber is cut, it does make a difference between a 223 cut, a 223 Wild, a 556, or any of the hybrid cuts. That chamber does make a difference in the cycling of the firearm as well. And of course, if you have a 223 chamber, don't shoot 556. Now you can get that reamed out. A quality barrel will say on the barrel somewhere exactly what the chamber is. Now keep in mind there are different companies out there of different quality levels, and I have seen companies that have their barrels say 556. However, when I've taken a gauge to it, it's actually a 223 cut chamber, and I've actually had to ream those out to get them to cycle. Now this particular one, this is a great barrel. This is a Rainier Arms. I'm not sure if you can see that on camera, but then it has the brand info. It has the chamber cut, the rifling type, etc. So a good quality barrel is going to have that information on the barrel. Don't rely on what's on the upper receiver. Now additionally, one thing that makes a difference is the gas system, which is the distance or length of the gas tube, the distance between the port and the travel of the gas to the bolt carrier group. That makes a difference, as well as the gas port. The gas port is this small hole right in the barrel right here. That's what the gas escapes out of, travels through the block, down the tube, into the carrier. So those things make a difference, and the size of the gas port makes a difference too. Some companies purposely make really large gas ports because they want their gun to cycle in the cheapest of ammunition. The downside is you have increased felt recoil, cyclic rate issues, you can have timing issues. The gun truly can be over-gassed. It's actually getting too much gas. And you have other companies that are using quality companies that are using smaller gas ports, reasonable sized gas ports, and they'll tell you, hey, this may not function the cheapest of the ammunition depending on how you have it set up. So AR basics is when you pull the trigger, the gun goes bang. We all get that. But what actually goes on, how the gun works, how it cycles, and everything like that under the hood may be new to some shooters. So what happens is when we go bang, we have that primer set off the powder. That powder creates pressure. It sends the bullet down the barrel. After the bullet reaches about this point, some of that gas, some of that propellant, that pressure starts to come up through the gas port and down the tube. As the bullet continues, we have all of that pressure building into the gas system. This distance from when the bullet passes the gas port by the time it leaves is called dwell time. And that depends on the different gas system, how much dwell time you have. There is optimal dwell times for different length barrels, etc. So we'll kind of get into that here in just a second. So as the gas pressure builds, it goes down the tube, goes into the carrier, goes down into the bolt, and cycles, unlocks it, and then you also have the energy still, once the bolt is unlocked and begins to its unlocking phase and rearward travel of the carrier, you also do have blowback as well. So it's not 100%. A lot of people think that just this gas that's coming in the tube is moving the carrier to the rear. And what the gas down the tube is really doing is it's unlocking and starting the process, but we still have that energy that also continues it as well. So it's a system that works together, but it is a locking system. That's why with your carrier, you'll notice when the bolt, if you look at just your carrier, the bolt does cam back and forth into a locked and unlocked position, similar to a bolt action rifle. I know it's not the same, but it's similar to how a bolt action rifle locks in. So that's kind of the operation 101. There's more to it than that. Maybe we can do a separate video on that if you're really interested. So as far as gas systems go, how did we get these different gas systems? Well, traditionally we had a 20-inch barrel, like as shown here, and we had a rifle length gas system, which is the longest traditional length gas system, is this rifle length. And what that basically means is it's a length that is an industry standard that was based on the 20-inch barrel. When the 14.5-inch barrels came out, that was a carbine, they came out with what's called a carbine length. And you can see the difference here. So if we were to install this here, you could see that it's a much shorter system, and that goes with shorter barrels. Like this barrel right here is a 13.7-inch barrel. It's for an idea I had for a project coming up to make an overall length of 16 with a fixed muzzle device that's pinned and welded to meet the ATF specs. But you can see here it kind of matches a similar dwell time to this longer barrel, and then it kind of is proportional. So when they had shorter barrels come out, they had to shorten the gas system. The pressure actually increases. Additionally, there's mid-length, which is kind of in between the two. So we have a carbine length, the rifle length, and then we also have the mid-length. Now the mid-length is very popular with 16-inch guns. It's very popular with some 14.5-inch guns, depending on the manufacturer, depending on the company that does that. But you can see it's kind of a in-between. If we were to look at that on camera, I'll get a close-up for you here. And then of course the rifle length, you can see the difference there in length. Now, are these the only three? No, there is a shorter one called pistol, and that's really popular in the 300 blackout, or like the 7.5-inch AR builds. They use a pistol length gas tube. And then there are some intermediates and different hybrid gas systems that aren't as mainstream, but there are some in-betweens. But the three main ones that you're going to see are carbine, mid-length, and rifle. Now, which one is the best? Well, number one, it's going to depend on your barrel. If you're shooting a 16-inch barrel, which is very common, I prefer a mid-length gas system because that still allows for a good amount of dwell time, good felt recoil, good pressures. If I was shooting a 20-inch or maybe even an 18, I like the rifle length. 14.5, you could do a mid depending on the gas port size. You can also do a carbine, and then like on SBRs, 10.5-inch, 11.5, maybe even this 13, the carbine length is much more common. So it kind of just scratching the surface there. I know I've talked a lot, but there's a lot of information under the hood of what's going on and what data is, because when I've worked on a lot of guns, I've seen a lot of gas-related issues, and if you add a suppressor to that, that can change the mix as well. So let's talk about buffers for a second. And the buffer is inside of the stock, and it reciprocates with, as the bolt carrier travels to the rear, there is a buffer and spring inside the receiver extension of your stock. A lot of people call that the buffer tube. It's really called the receiver extension. Now, what the buffer does in combination with the spring, so when the gun goes bang, pow, bolt carrier cycles back, it is stopped by the buffer, and then it returns with the energy of the spring. Now, why are there different buffers? Well, we have the rifle buffer, which is shown here. The rifle buffer goes with traditionally the rifle gas system and the rifle length receiver extension. So these longer stocks have the longer buffer. Well, when the carbine and the collapsible stock market started to, be introduced, they couldn't fit this in there, so they needed something shorter. So then they came out with the carbine buffer. and a carbine spring to go with that shorter receiver extension. Now, a common question I get from new AR-15 owners is, okay, I have this buffer, I took it apart and I shake it and it's loose, there's play, there's something loose in there. Well, that's actually how it's supposed to be. It's almost kind of like a dead blow hammer in a way. And if we were to take one apart, this comes off, there's a roll pin that holds it together. You actually have a combination of weights in here. Now this is a carbine, these are all the same weight, but we can also increase the weight by swapping this out for a tungsten weight, which would be heavier, and that would have a marking traditionally on the face of H1 or H. H2 would have 2, H3 would have 3, and then there's also different, heavier buffers on the market for different configurations, pistol, things like that. Which one do you use? Well, some people say use the heaviest buffer you can that still cycles your gun. You can, but keep in mind if you get into adverse conditions or anything like that, it could affect your cycling. So the real reason why heavier buffers existed initially was to slow cyclic rate with machine guns and to prevent bolt bounce, which is where the bolt carrier cycles, it comes back, but it actually bounces, and then you don't get repetitive full auto fire. In the semi-auto sporting community, most people never know if their gun is bolt bouncing or not. It's really a machine gun thing. So we have heavier buffers for that. However, we can increase the feel of a gun with a slightly heavier buffer and increase reliability. So on a 16-inch gun that's properly gassed, a mid-length, I'll usually run an H1 buffer. Maybe if I'm shooting suppressed, I might run that a little bit differently too. So that's, again, kind of just scratching the surface. But this is just meant to be basic 101 gas system, basic 101 buffer. I hope that helped kind of answer your questions about gas basics, buffer basics. There's a lot to it. If you have questions, I would recommend seeking the assistance of a really competent gunsmith or armor, especially if you're building. If you have more specific questions, please ask. We'll do more videos on this topic in the future, as I realize that you might still have some questions, but there's just only so much we can pack into one short video to get started. So I hope you found this helpful. If you have any questions, please leave comments in the section below. We really do want to hear from you. And if you have any ideas for future videos, please let us know. Please like, share, and subscribe. It really does mean a lot to us. It really helps the channel grow. And we look forward to seeing you in more future videos. Thank you very much for watching, and have a great day.